Think about this for just one moment. What if you had one chance, just one, to go back? To that moment you lost. That person you can never see again. That mistake you would give anything to undo. What if time travel was real? This is not science fiction. The greatest minds in human history, from Einstein to today's quantum physicists, have taken this question completely seriously. And today we're going to answer it with real science, real experiments, real proof.
No fantasy, no guesswork.
Just the truth, however strange it may be. In 1905, Albert Einstein published something that shook the foundations of physics. He said, "Time is not the same for everyone. Time is relative. Time can warp. Time can speed up or slow down, depending on how fast you are moving and how strong the gravity around you is." He called it the theory of relativity. And here's the most important thing. This is not just a theory anymore. It has been proven, repeatedly. And right now, today, you are using it without even knowing it. And Scott is not even the record holder. Russian cosmonaut Sergei Krikalev spent a total of 803 days in space across multiple missions. By the calculations of relativity, Krikalev is approximately 20 milliseconds younger than he would have been if he had stayed on Earth his entire life. He is, right now, the most time-traveled human being alive on this planet. So time travel is not coming. It is not being invented. It is already happening. The real question is, can we do it in years instead of milliseconds? And can we go backward? In 2025, physicist Lorenzo Gavesino at Vanderbilt University published research showing that quantum mechanics and thermodynamics together might resolve the paradoxes of time travel without breaking the laws of physics. The science is moving. Every year, we get closer to understanding what was once considered impossible. Now we come to the hardest question of all. Can we travel to the past? And this is where physics becomes genuinely complicated. Imagine you build a time machine. You travel back to 1920, and by accident, you prevent your grandfather from ever meeting your grandmother. They never marry. Your parent is never born, which means you are never born. But if you were never born, you could never have built the time machine. So you never traveled back. So your grandfather does meet your grandmother. So your parent is born. So you are born. So you build the machine. So you travel back. This loop never resolves. It is a logical contradiction that has no exit. This is the grandfather paradox, and it is a fundamental challenge to the entire concept of past time travel. Stephen Hawking spent years thinking about this problem. His conclusion, which he called the chronology protection conjecture, was that the laws of physics themselves conspire to prevent past time travel. Nature, in effect, protects its own history. He even designed an experiment to test this idea. He organized a party for time travelers. He sent out the invitations, but only after the party was over. So only someone traveling from the future could have received the invitation in time to attend. He set up the champagne, the glasses, the decorations. Nobody came, but quantum physics offers a different answer, and it is a fascinating one. Physicist Michio Kaku argues that if you travel to the past and change something, you do not change your own past. Instead, you create an entirely separate timeline, a parallel universe. Your original universe continues unchanged. You have simply branched off into a new reality, one where things went differently. This is called the many worlds interpretation, proposed not by a science fiction writer, but by physicist Hugh Everett III at Princeton University in 1957. Your grandfather paradox disappears because you are changing someone else's grandfather in a universe that is not yours. This is not all theoretical. Real experiments are happening right now in laboratories around the world. Researchers at the University of Cambridge used quantum entanglement to simulate what backward time travel might look like at the quantum level. Their experiments showed that in quantum systems, the arrow of time is not always what we expect. Under certain conditions, information appears to move in ways that defy our everyday notion of before and after. The researchers were careful to say, this is not a time machine, but it is a window into the fundamental nature of time itself. Then there is CERN. the Large Hadron Collider, the most complex and expensive machine ever built by human beings. A 27-kilometer ring buried beneath the border of Switzerland and France. Inside this ring, particles are accelerated to 99.9999% of the speed of light. And what scientists observe there is direct, irrefutable proof of time dilation. Subatomic particles called muons are produced in the upper atmosphere. They are unstable, they decay almost instantly. But when they travel at near-light speed, they live far longer than they should. Their internal clock has slowed down. We see them hitting our detectors on the ground every single day. They should not be there, but they are, because of time dilation. This experiment has been replicated thousands of times. The result is always the same. In 1971, physicists Haffel and Keating carried atomic clocks onto commercial airplanes and flew them around the world. When they compared those clocks to identical clocks that had stayed on the ground, they were different, by exactly the amount Einstein predicted. Time bends. We have measured it. We have proven it. It is not in question. So here is the honest question. Practically speaking, how far are we? For significant future time travel, we need a spacecraft that can approach the speed of light. The fastest human-made object ever built is NASA's Parker Solar Probe. It travels at approximately 690,000 kilometers per hour. The speed of light is 1,079,252,848 kilometers per hour. We are currently moving at about 0.064% of light speed. We need 99.99%. That gap is not small. That gap is civilization defining. For wormholes, we need exotic matter. We have theoretical frameworks, but we have never produced or harnessed it at scale. Will it happen in our lifetime? Almost certainly not. Is it impossible? Absolutely not. 100 years ago, human beings had never left the ground in a powered aircraft. 50 years ago, the internet did not exist. 20 years ago, the smartphone was science fiction. Science does not stop. It never has, and it never will. So, can time travel actually happen? Here is the honest, science-based answer. Time travel to the future in small amounts is already happening.
Right now.
Every astronaut on the ISS is a time traveler. Your GPS would not work without accounting for it. Particles in the LHC prove it every single day. Time travel to the future, in significant amounts, is theoretically sound. The mathematics is airtight. The only barrier is engineering. And engineering is something humanity has always, eventually solved. Time travel to the past. This is where we must be honest. There is currently no confirmed mechanism that allows it without paradox. Physics itself may prevent it. The grandfather paradox remains unsolved in any practical sense. But here is what I want you to take away from this video. The fact that we are asking this question seriously, rigorously, in laboratories and peer-reviewed journals says something profound about our species. Every great discovery in human history began as an impossible question. Heavier-than-air flight was called a fantasy. Splitting the atom was called theoretical nonsense. Reaching the moon was called a dream. Einstein was a patent clerk who wrote a beam of light in his mind. Somewhere out there, right now, a teenager is sitting in a classroom, staring out the window, asking a question that will change everything.
We do not know when. We do not know how.
But we know this. The universe has never cared about what we thought was impossible. If this video made you think differently about the universe, about time, about what is possible, then it did exactly what it was meant to do. Subscribe for more videos where we take the biggest questions in science and give them the honest, deep answers they deserve. I'll see you in the next one. Until then, keep asking questions.